Devlog 4 is organizing stac-geoparquet to enable efficient access by ID. So in our previous devlog, we did some work around organizing ITS live data, which is glacier surface velocity, catalog, um, organizing that into partitions. In this case, we're going to do a little bit of extra work to create a second partition data set. So just as a refresher, the original data were stored in these spatial partitions with Parquet files underneath them sorted by year. We did some work to reorganize them using DuckDB into yearly partitions with single files underneath each. As a spoiler, in this devlog, we're going to do an additional partitioning step where we're going to still partition by year, but modify the IDs. So we're going to have this replace ID statement here and append the date time in this concatenated format to the front end of the IDs. And then we are going to order by ID as well. So we're actually going to sort the data. That makes the partitioning a little bit slower, but we're paying upfront for wins later. So to walk through what that looks like, we're going to use DuckDB Notebook to explore our data sets as we've uploaded them to S3. We're going to load the spatial extension. We're going to disable the external file cache. This is not something that you need to do if you're doing this. I'm disabling the external file cache in this case to get truer measures of how long it takes to do things because DuckDB is smart and tries to save some results down to a local file cache, and that makes things look like they're running faster than they would if you hadn't done any prefetching. So in this case, just to show how things are working, I'm going to not do that prefetching. And so you can see I'm going to kind of run cells as I go through them, but you can see it doesn't take super long to to read all or figure out how many things there are in the original partition data set. So I'm going to be hitting both the original partition data set and the sorted one. And you can see the same is true for hitting the sorted data set. It took roughly about the same amount of time. You can see there's the same amount of items in each. Now I'm going to do a slightly different query. I'm going to filter down by year. And so stack doesn't normally have a year attribute, but in this case, we added one when we did our partitioning. And so we can use this year attribute to ensure that our DuckDB query is only going in, hitting the file that's within that year equals 2008. That's kind of how the Hive partitioning works. So this can be useful if you know that folks will have access patterns where they will only need a subset of your data. If you set up your Hive partitioning with those keys, DuckDB can use those keys to filter down transparently to the person making the query. Now, you obviously can't do this for every single variable, so you only want to pick the things that are really important to whatever the use cases you're trying to support to partition by. And if we look to see what that looks like, we can actually use the describe functionality to show that we're only touching one file. So we're not touching any of the files from other years. We're only filtering by that year, which is pretty handy. We're then going to do some quick searches to get single IDs. In this case, I'm going to dive into the data set, into that 2008 year, and find the 10,001 item. The idea here is to try and find an item that's not near the beginning or the end of the data set, because the data set goes to 2024. We're trying to just find an item in the middle that hopefully is kind of representative of being hard to find within, what is essentially 10 million items. So I'm going to do that for the partition data set, and then I'm going to do that for the sorted data set as well. And you can see that these are going to be roughly the same IDs, except that the bottom one has that date time prepended to it that we use to sort. I'm not going to run the next two queries because they take a minute or so. But in this case, here, this is showing an example of going into that partition data set, using that ID and finding that one item. You see it took a little over a minute. And if we go into the explain plan here, you can see that we fetched over 100 megabytes of data to do that request. And that's because we're having to look through a bunch of different things to find that item. You can see we come down and we actually touched all 44 of the items in our partition data set. When we do the same thing for our sorted data set, you can see here's the ID with that timestamp in front of it. We're going to run things much faster. And I'm going to have it explain. I'm going to do this live because hopefully this doesn't take more than, roughly 30 seconds. And I can fill the space in the video. But what's happening here, and there you go, that took 13 seconds. You can see that we only fetched 40 megabytes, which I'm on a relatively slow Wi-Fi right now, and so those bytes matter, instead of the 130 that we fetched before. We still had to touch all 44 files, but because of the sorting, we fetched less information from each file, and so we were able to find that entire item, that entire stac-geoparquet item with all the information in it, in less time because we had sorted it beforehand. It's pretty handy. I did a blog post to this effect that I will make sure I put in the show notes, but just thought I'd walk through what was going on there with a little bit of live DuckDB queries.